So in previous videos, we've been looking at how to set up dev containers, how to set up our local version of an LLM, most likely Llama 3. That's very popular right now, and also how to use the CrewAI framework to seamlessly, have multiple agents work with each other and and understand how all this is being used in the industry in a more standard way. So by using our dev containers, now we have simplified the environment management and containerized our AI agents. But what's the right way of using CrewAI? So I've seen there are multiple different ways in which people have been implementing, and it's all over YouTube. And none of the ways is an incorrect way, but there is a standard way that CrewAI provides to implement its agents, and I'd like to use that standard way because it really streamlines the whole process, and it makes the separation of concern into what a task is, what the definition of an agent is, and where those definitions sits in terms of code versus some verbosity that is built in, that is moved out of the code and put into their own individual YAML files. So first, I think we need to understand what is an agent. So agent is an entity that can make use of intelligence that we provide to it, and the intelligence comes in via some kind of large language model. And after we have given the agent the intelligence, it has the power to do everything that you can do on, let's say, ChatGPT, right? So you go in and you type whatever you want to type on ChatGPT, and you are talking, having a conversation. All that intelligence you have provided to an agent now. So programmatically, you have, in a way, I'm using this word very loosely, but you can think about it like that, that programmatically you have made an agent talk to your ChatGPT or your local instance of Ollama LLM, right? But an agent's scope doesn't stop there. Yes, it can talk to an LLM for sure, but it can also take actions on top of it. And the way it takes action is that while reasoning with certain types of prompts that it is giving to the LLM, it comes back and it talks to itself, and it says, whether the answer that I got, or in my thinking process, whether whatever I talked to the LLM, whether it was the right answer or not. And this is where it self-corrects. It heals itself by asking the question again, a follow-up question. Maybe it has a thought, and it comes up with a follow-up thought that, hey, whatever answer I got by the first prompt doesn't really answer the question. So let me follow it up with a secondary thought. And it goes into a multiple iterations that way, and goes back and forth, multiple iterations. And it also has at its disposal not just the LLM, but certain tools that are provided to it, right? So what are tools? So these tools are, let's say, you can give it the power to go online and to search by using DuckDuckGo, or you can give it the power to search by using Exa, right? Or you can do you can give it the power to modify your files on your computer, right? Or you can give it the power to go right into the database or scrape a website, right? So you can actually empower your agent to not only go in and converse with your LLM, right? Like ChatGPT conversation that you're having. Not only that, not only go back, iterate on its conversation with the LLM till it refines and believes the answer it got is correct. Not only all that, but you can also hand it some tools where it can go out, reach out to internet and finish its task. So that's one agent now. But this is where a multi-agent platform comes into the picture, where your scope doesn't stop with one single agent. You can have an agent that has the capability of reasoning and it has some tools at its disposal. You can have another agent that specializes in a different area, has a reasoning capability, and has some other tools at its disposal, right? And you can create a manager agent where that manager agent can help orchestrate the whole conversation, where you can have one agent interact with other agent or one agent being orchestrated by the manager agent, which can fulfill the whole set of requirements and make sure that all the agents, while they are performing their tasks, they are doing it in a meaningful way, right? So we can either have a sequential arrangement of the tasks that these agents are performing, or we can do it in a non-sequential way where the manager concept in one of the recent CrewAI versions, it has come up. So CrewAI actually implements something from Langchain agents, a concept called a ReAct agent, right? So if we take a look over here, there are various different agent types in Langchain. And Langchain is just a framework, it's one of the most popular frameworks that people have been using for AI. And I absolutely love what the developers over here have done. So they have created these agents for other frameworks to utilize, which is what CrewAI does. So in CrewAI utilizes one of the agent types, which is the ReAct agent. And this ReAct agent, this is not the framework that we normally use, right? The ReAct framework, no, it's not that. It is actually a type of an agent that utilizes a combination of natural language processing from the LLM, and then it has the capabilities to interact with its environment and perform certain tasks, right? So the name ReAct actually comes from reasoning and acting. This is where I was talking about it can reason using the large language models that it has access to, and it can act based on the tools that we have made it available to, right? So it has a task-oriented dialogue management built in, where it can do reasoning, it can do decision making, and it has ability to interact with external environment and with different agents in order for it to fulfill its task. And this is huge because once you make something like this available, now there can be other frameworks that can kick in and they can put this under the hood and they can create like a easy to use frameworks on top, which is what CrewAI is. So CrewAI in a way builds on top of Langchain, and CrewAI agents then have this ability to so like if you take a look at Langchain's ReAct agent, I mean, you can implement it too, and maybe you probably won't need the CrewAI kind of framework if you want to go pure vanilla and use the ReAct agent straight up from Langchain. It'll be a lot of work for you, but it is possible, definitely. You do not need a specialized framework. But if you choose to use CrewAI, then these guys have built in certain easy to use features that pick things from Langchain, ReAct agent, build on top of it, and give you the whole full feature set of a multi-agent framework, right? So Langchain gives you a single agent kind of framework or agent building process. CrewAI builds a crew of AI agents and helps you in having the conversation between multiple agents together, right? So this is a documentation page for CrewAI. It's a pretty good page. I like the way they have listed down the capabilities of an agent, what are their different attributes, how do you create an agent and all that. But even though they have listed down how to create an agent, this is actually not their their final way in which they want us to create the agent, So if you generate their template project, it actually diverges from this particular view of how they want us to create an agent based on this documentation. And this is why there is some discrepancy in, shall I put all the backstory in here, right? I mean, can you? Yes, you can. But when you do that, your agent kind of becomes very bloated, and it doesn't look very good to have all the data right in there, right? So there has to be an elegant way, which they did, and which is what I want to show you over here. But before I jump into that, let me just see if I can find CrewAI Langchain React agent. Let's search that. I believe there are some images. Let me just take up this image and show you that if there is a task that an agent is assigned to, this is where the agent first goes to the LLM. I mean, it's large language model. It could be your OpenAI connected API, or it could be your local large language model, and it does the reasoning and it iterates over the reasoning, multiple times it iterates. And when it cannot get an answer by itself, it also sees that, hey, there is a tool for me to use, right? I can go out and search, and it can utilize a tool. It can go outside, maybe do a search online for something, get the result back, and then it will come back to the LLM. It will do the reasoning. Hey, do I have an answer? And if I don't, then let me just, go through some other iterations, refinement. And if I have to use the same tool, I'll use that, or some other tool, I'll use that. And I'll reach out to external environment and try to get my job done over here, right? So I really like this particular image that has been presented over here. Kind of paints the picture perfectly of what I was trying to explain earlier. All right, so let's go back to this particular repo that we have. So I did not show this repo in my previous videos. So if you are looking at this for the first time, this is the reason. But I tried to paste the link to this repo in my previous videos too, and I'll paste it over here as well. So there are two branches. There is one branch over here that is a very simple dev container branch, right? As it says, basic requirements branch, right? The reason why I say requirements over here is because then in this particular setup, you are going to use requirements.txt file, which has, just one dependency on CrewAI, right? So this is the very basic way in which we have the dev container setup. In one video after that, I have shown how you can use poetry in order for you to utilize dev containers, right? So in poetry, you will need this pyproject.toml file, right? So this particular file, and you will need CrewAI and CrewAI tools. And if you see this particular version installs the CrewAI tools also, along with the CrewAI version that we are looking at. So we definitely want 0.28.8 version over here. I believe this is the version where we can make use of the CLI. So let's make sure that we have the newer version that is mentioned in this particular project, right? So pyproject.toml file will need this, and we need this Docker file and dev container.json, and these two are needed for you to create your dev container. And I'll show you a trick on how you can set up your dev container using your CrewAI, and then use the same dev container to carry forward your CrewAI development. And if it doesn't make sense, you'll watch me do all this. But just think at a very high level. It's a two-stage process. Stage one would be creating a dev container with the CrewAI CLI in it, right? And that CrewAI CLI will create a project, an empty project for us. Step two would be to use that empty project, which will already contain your pyproject.toml file in it, right? So we'll use that particular empty project and move our .dev container folder in it and restart our whole workspace so that we can code in that empty CrewAI project. Okay, all right. So there is a lot to do over here. Let me start coding and let's get going. So step one. So let me do this. Let me, in my folders over here, let's go to a new folder and let's create YouTube. YouTube, no, we want CrewAI 01, and it doesn't matter, I'm just trying to come up with a name and failing at it. And let's cd into it. So I currently have WSL over here. You don't necessarily need it for what I'm doing right now. You need it for installing Docker and for having your, so let me quick show you. I mean, all this has been shown in the previous videos, but I want to just quick do a recap. I want to show you that in my Docker, I'm using the WSL2 based engine over here. And that is why WSL has been enabled, right? And if you do not know what this interface is, this is Commander CMDER, and I prefer it over any other command line tool in Windows. So it gives me a very nice interface to work with. All right, so let me close the settings over here. I already have my Ollama running on 11434, which is awesome. And we'll see when we create the dev container, what changes on our Docker interface too. Okay, so we have our empty project over here, right? Step number one is to go to the dev container CrewAI, this particular project. Go over here on the code, on the HTTPS, click on this button, copy it, and then go to your command line. You are already in an empty folder, right? So you are already in an empty folder, and all you have to do is git clone, and you'll paste this particular, oh, no, not this. We want to copy this HTTPS link, right? So git clone this and hit enter, and you will be done by cloning this, right? So now if you do git branch, you will, oh, we need to enter that for sure, right? And then we do git branch, and you will see that you are on the main branch, but you don't want to be on the main branch. You want to be on the poetry branch, right? So we'll do git checkout, and what are the two options over here? Poetry branch, right? And now we are on the poetry branch. So if you do git branch, you will see that you are no longer on the main branch, you are in the poetry branch. And this is very important because the code that we have, the base setup code that we have, is in the poetry branch, right? So if you do ls -la, you can see that you have your stuff in here. And let's do a quick cat on pyproject.toml file, and you will see that you have the right pyproject.toml because of the CrewAI version that is over here. All right, so once you have all this set up, you can now start your code. So code dot gets you started with this, and it opened up in my other window. Let me pull this over here. And yes, I trust the authors, that's me. And we have our empty project over here, right? And I'll also, let me try to put this over here, and maybe the dev container, well, the Docker over here, right? So you can observe that once we do certain builds over here, they show up on this Docker window also. So step number one, after we have pulled our empty dev container project on the poetry branch, right? We'll go over here, we'll reopen in the container, and while it is reopening in the container, yes, we trust everything, and it is trying to build, you will see that there is a build process that is started over here. So very soon it's resolving the dependencies, the builds. Where is the build? Maybe it shows after it is done how much time it took. So let's just wait for it. Let's just wait for it to see once it shows over here. So it takes in on my machine around a minute to minute and a half for all the builds to finish successfully. Yep, there it is just now. So it took 48 seconds, and it takes, so it only populates separately once the build is done, and not like while it is building. Okay, and so that was the builds tab. Let's go back to containers tab over here, and it says that this particular container is running. All right, so now if you open a new terminal, I'll move this out now. We are done with the Docker instance of it for now. And if we open the terminal and if we check a couple things over here, right? So let's check Python version over here, right? And we have Python. Let's check poetry version. We have poetry, right? So we have Python, we have poetry, and CrewAI. So CrewAI is recognized, the CLI is recognized now. And if I do a help, right? So it shows me the top level commands. So there is a help, right? That's what we are running. And then there is a create, right? To create a new CrewAI project, right? So there isn't a lot available in help, but fortunately today we are here only for create. So that's all that we're gonna do. Before I execute this, I want to just quick talk about the project structure that it is now and how it will change after we have executed it. So we already have a pyproject.toml file, right? So this is our pyproject file. Once we create a new CrewAI project, it will create a subfolder within this folder, and that subfolder will again have a pyproject.toml file. Right? So let's do that and visualize it. So if we do CrewAI create, and let's give it a name, sample crew or CrewAI sample. I like that one more. Crew underscore AI underscore sample. How about that? Okay, so that is what we are going to create, a new project called CrewAI sample. And once we hit enter, it is now actually going to create a whole template of various files over here. So you see the files that it is creating is inside this particular folder, CrewAI sample, pyproject, readme, and all that it has created. And if you see, this is how it has created all the files over here. Right now, you see there is a pyproject.toml file already in there, right? And there is one pyproject.toml file outside that you have. So this is what I was talking about, that we needed the original dev container for us to create a sample project, but we don't need this original project anymore. Our project now is this particular project, right? So what we need to do is two things. First, we'll go to the Docker desktop and we will stop this particular Docker instance, and we are done with this, right? So the purpose of that Docker instance was to just run the CrewAI create command, and we are done with it. Step number 2 is that we will go in here and move this particular dev container folder inside the CrewAI sample project, right? That's it. That is all that we have to do. We do not need any other folders. We do not need any other files. We might as well go ahead and delete all this. We don't care, right? We just need this particular folder and .dev container in this folder. Okay, so that is all that we have done. we copied over the .dev container folder inside the CrewAI folder, and this already has py.project.toml file, so we are not worried about anything else to be put structure wise, right? So now we have to just do cd CrewAI sample and do a code dot in there, right? So we are now opening it from inside, and let me close all this, and the structure that you see is the same now. So this is what we've been talking about in the previous video, that in order for our dev container to work, we need to have a dev container at the root of the folder, .dev container folder, and py.project.toml file at the same level as the dev container. So now these two requirements have been met. So before I go ahead and proceed with talking about what these different things are, let me just go in and reopen in container over here, right? So it is going to reopen in container, and it's going to do a build. And if we come back over here, this is our Docker. Let's just open this also and then open Docker over here. So if we come over here, it is going to perform a build. And we know that the build usually takes 48 seconds, and the build is actually having about the same amount of things in it, because the py.project.toml file is almost identical to the previous ones. In a previous one, in terms of oh, there's the active build section over here. This is what is being done. Oh, I should have been on this active build and not in the build history. Okay, so that is done, and the build history took 35 seconds this time. Probably some of the data was cached, or maybe the internet connection was faster, but we were able to get the build done. Okay, now let's take a look at what has changed and what this project structure looks like. So very first thing, there is a config folder over here now, and in this config folder, all the definitions are residing. So there is an agents.yaml file, and in this particular one, I think there are two agents. You can see researcher, their role, goal, backstory, and in this YAML file, all this description exists. Similarly, there is another agent over here, and then you can make a copy of this down below and have a third agent also if you would like. Excuse me. Similar to that, in the task, all the verbosity, right? Everything that was originally written down has now been written down in the code, right? So by code, I mean in the Python, in the py files, have been moved out into the YAML files, because it makes more sense to keep all this text outside instead of keeping it all inside, right? And we have also done a kind of separation of concern in terms of what is configuration, whereas what is code, right? So all this kind of belongs in the configuration section, and we can easily, change this text in future without messing with our Python files. All right, so this is the configuration for agents and tasks. And if you go to your crew.py, or actually the code execution will start at main, where you will have that kickoff command over here. But the mapping of the agents and the tasks and everything is being done in the crew.py file. So you can see that the agent config is being read from config/agent.yaml, right? So this is the file that we saw earlier. The task config similarly is being read from tasks.yaml file, which is in the config folder. And there are some decorators over here that are defining a researcher agent, and it is pulling the researcher agent from the agent config researcher, right? So if you see over here, this is pulling it from here, from agent config researcher. And you know what, let's just split it, right? Okay, so now we can easily see that our researcher is getting pulled from here, and our reporting analyst is getting pulled from here, right? So you can see the mapping that is being done. Similar to that, there is tasks, and now our task, research task, which is annotated by task, is also doing the same thing. So we have a reporting task and research task that you can see is being mapped over here. And the crew itself is, in this case, sequential. So this is not having some kind of managerial thing that I was talking about earlier. So in this case, it is sequential. So once the first agent gets done, it goes to the second agent, and it is doing one after another instead of two agents having a manager agent, and they are being done in a hierarchical way, right? So it actually does talk about it, that if you want to do it in a hierarchical way, then there is the process.hierarchical that you can use for it. So in this example, there are only two agents, so it made sense for them to just implement it as a sequential process, right? And if you go to the main.py, it is just, like initial simple run, and it will run your project by doing the crew.kickoff. Okay, all this is good. However, there are a few things that you will need over here for this to work. So number one, you need to provide your, let me close this side. So everything opens in just one window. So environment. So if you are using your OpenAI, then you can just use your OpenAI key over here. I'm not using it. So I'll be showing you how to do all this using your local Llama, right? So using your Llama 3. And that is what we'll be doing. But before we do that, there is a README file over here also that I want to take a quick look at to show you what this README does. So in README, it says how you can set up this project. We are not going to do this. We're not going to do pip install poetry and all that, because we have done that already. We have done that while we were initializing our dev container. We don't need to do the pip install poetry. However, we do need to run these two commands over here. So let's go to terminal and let's do a poetry lock. And it is going to resolve the dependencies, and it is going to create your lock file over here, right? And that's good. And then we can do a poetry install, right? And then we have our CrewAI sample ready. And then we can do a poetry run CrewAI sample. And when we run this is not going to work for us right away, especially because we have not provided our OpenAI API key yet, right? So let's run it anyway, and let's see that error message, and then I'll show you how to connect a local model over here. So let's run it, and while running it, it is entering our CrewAI kickoff, and obviously it's gonna give us an error that, well, before I show you the error, at least it shows that the CrewAI agent framework was working, because it tried to make an attempt to connect to our language model. The agent tried to do that, but it couldn't, because our key, OpenAI based client and all that, it couldn't connect. There is an invalid API key over here, right? And that is why it is saying up, cannot connect, please fix that key over there. But we don't even have the key. We don't need to fix the key. What we do have is, let's copy some code from our previous project. So in this test, in the same poetry branch, right, we have test.py, and over here there are these 3 lines, right? And these actually import OS2. So let's copy that import OS first and put it in our crew.py over here. So it is available. So let's paste this import OS, and let's go back and copy these 3 lines. Right? And that's it. So now we are saying that OpenAI API base is our local host, and And why does the local host work? We've been talking about it for a very long time, but let me quick show you again. In the dev container over here, we have this particular line, which does the network host. And the deep explanation has been given in a previous video why and how all this works. So you can watch the previous video to see that. But this is the key for all of this to work from the dev container to your other Docker image where you have things installed, Ollama installed on 11434 port, right? So let's go back to our crew.py file. And so we specified our OpenAI API base URL, and we have specified the model name Llama 3 over here. And the API key does not matter, it just needs to be populated. So whatever is here works, right? So let's save this file. I do this mistake a lot of times. Don't save it, try to run and it doesn't work. And then we try to figure out why it's not working. All right, so by making these 4 changes, we are good. And we'll run this thing again. And let's do poetry run CrewAI sample, and it will run. And while it is running, I'll also pull my GPU over here. So you can see that the GPU will start spiking once the CrewAI starts making the LLM. So now it has just started making the LLM requests, right? So I have a RTX 3090 water-cooled system over here. It's a custom loop water-cooled system, so it's not making a lot of noise, but trust me, the GPU is actually spiking and it is making calls. It is trying to do whatever the agents were requested to do. And let's see what it comes up with, like without having any external tool available to it. All these agents are just having back and forth communication. They are trying to talk to each other. They are trying to see if they can come up with something, and they're trying to reason with themselves too in terms of their own intelligence, whatever is built in to them. So Llama 3 is trying to do all this right now by itself to see if it can come up with whatever task it has been thrown at without using any external tool over here. So this can actually take a lot of time. I mean, there is no restriction, I believe, on these agents right now, even though. So while I say this, in the CrewAI documentation, there is a restriction that we can put on it, right? So we can put max execution time, and we can max iterations. We can put that how many times an agent can, like loop through before it is forced to give its answer, and all those things. I mean, that's why I like this documentation over here. All these agent attributes, they're pretty good. They have just moved out some attributes into the YAML file, and that's why the newer framework I really like. All right, let's take a look if the. Oh yeah, so you see how my GPU processing stopped, which means the agent must have come up with some kind of answer, which is probably not good, but let's see what it came up with. Its final answer is the current project aims to provide a detailed information about the specific. Okay. Interesting. I mean, it came up with something, right? It came up with something, and without having access to any external tool. I'm glad at least it came up with something instead of just, kind of bugging out and giving up. Okay, so all that being said, now we have a working CrewAI base project over here with a dev container and using the template that CrewAI provides by creating the CrewAI create project command. All right, please let me know if you like this video, and if you have any comments. Hopefully the visuals over here were better now. I'm not, even though I am still on 1440p monitor, I've tried to maximize the fonts on appropriate screens so that you guys can view the video properly. Thank you very much, and I'll see you next time.